On this RAM 1500 Classic with the 3.6 Pentastar, P0335 is a crankshaft position sensor circuit code. In plain terms, the PCM may not be seeing a crank signal it can trust. The truck may crank longer, run poorly, stall, turn the MIL on, or if equipped, disable stop/start while the code is active. The fault area can be electrical, like the 5-volt feed, signal circuit, sensor ground, connectors, or the PCM-side, but it can also be mechanical around the crank sensor mounting area or the target wheel. Work it in order so you do not turn an intermittent connection or a target wheel problem into a parts guess. This monitor runs while the engine is cranking and while it is running. During cranking, the PCM is looking for the crank signal to lock after the cam signal is already locked. If it cannot lock the CKP signal for more than approximately 2.5 seconds, the code can set. With the engine running, if the PCM loses crank position and cannot relock within approximately 0.15 seconds, the code can also set. Treat those as the operating gates. Use the captured conditions to try to make the fault show itself again. Before going deep, start with the basic system checks. Then check for any applicable bulletins or PCM flash updates related to P0335. If one applies, handle that first, then verify the repair and confirm the code stays gone. If nothing applies, use the scan tool to read codes in every ECU, record the codes and environmental data, and save the scan report and related data. Clear the codes, turn the ignition off for a minimum of 10.0 seconds, turn the ignition back on, and operate the vehicle under the conditions that set the code. Then read codes again. If P0335 returns, continue into the active circuit path. If it does not return, move into the intermittent harness and connection checks. When the code does not come right back, treat it like an intermittent until proven otherwise. With the ignition off, first make sure the CKP connector is fully seated and the primary lock is engaged before disconnecting anything. Start the engine and wiggle test the harness and connectors to try to duplicate the problem. Then shut it off, disconnect the PCM and crank sensor connectors, and inspect for chafed or rubbed wiring, pushed out terminals, bent terminals, water, corrosion, and connector damage. Also look at the crank sensor mounting area for debris, damage, or a loose sensor. If you find a problem, repair it and verify the repair. If not, check the vehicle history for crank sensor-related codes within the past 90 days, and pay attention to whether the vehicle was serviced for a crank sensor fault within the past 30 days. If repair history shows a recent crank sensor fault and the crank sensor was already replaced, do not just put another sensor in it. Wiggle test the harness and connectors again, and if you still cannot duplicate it, remove the sensor and inspect the mounting location and target wheel through the CKP sensor bore while slowly rotating the engine by hand at the crank damper bolt. If a problem is found, repair as needed, perform the cam/crank relearn, and verify the repair. If the vehicle had a recent crank sensor fault but the crank sensor was not replaced on that visit, the path calls for replacing the crank sensor, performing the cam/crank relearn, and then verifying the repair. If there was no recent crank sensor service history and the checks did not find anything, reconnect the harness connectors and clear the code. The most likely cause was a poor connection at one of the harness connectors. If P0335 returns during the confirmation drive, look back at the recorded codes before testing the CKP circuits. If any 5-volt reference codes are present, diagnose those first. If there are no 5-volt reference codes, turn the ignition off, disconnect the CKP sensor connector, turn the ignition on, and measure the 5-volt supply circuit at the CKP sensor connector. The expected range is between 4.8 and 5.2 volts. If it is below 4.8 volts, repair the 5-volt supply circuit for an open or high resistance. If it is above 5.2 volts, repair the 5-volt supply circuit for a short to voltage. After either repair, verify the repair and confirm the code stays gone. If the 5-volt supply is in range, measure the CKP K24 signal circuit voltage at the CKP sensor connector. It should also be between 4.8 and 5.2 volts. If that signal voltage is in range, turn the ignition off, disconnect PCM connector C2, and check the K925 sensor ground circuit between the CKP sensor connector and PCM-C2. Resistance needs to be below 3.0 ohms. If the sensor ground is not below 3.0 ohms, repair the K925 sensor ground circuit for an open or high resistance. Then verify the repair. When the 5-volt feed, CKP signal voltage, and sensor ground all pass, move to the mechanical side of the crank signal. Disconnect the battery ground cable, remove the CKP sensor, and inspect the sensor mounting location for damage or foreign material. Then rotate the engine and inspect the target wheel if possible. A bore scope through the CKP sensor bore is used while the engine is slowly turned by hand at the crank damper bolt. On stamped steel targets, watch the light reflection on each tooth. A bent tooth changes where the bright spot appears compared with the other teeth. On powder metal targets, look for a tooth that is dull or non-reflective compared with the rest, which can indicate a broken area. If there is damage at the mounting location or target wheel, repair the mounting issue or repair or replace the target wheel or pulse ring as needed. Perform the cam/crank relearn and verify the repair. If no problem is found in this path, the procedure calls for replacing the crank position sensor, performing the cam/crank relearn, and verifying the repair. If the CKP K24 signal circuit voltage was not in the expected range, continue with circuit isolation. With the ignition off and PCM connector C2 disconnected, check for continuity between ground and the CKP K24 signal circuit at the CKP sensor connector. If there is continuity to ground, repair the CKP signal circuit for a short to ground and verify the repair. If there is no continuity to ground, measure resistance of the CKP K24 signal circuit between the CKP sensor connector and PCM-C2. Resistance needs to be below 3.0 ohms. If it is not below 3.0 ohms, repair the CKP signal circuit for an open circuit or high resistance and verify the repair. If the CKP signal circuit passes the short to ground and resistance checks, do a full connector integrity check before calling the PCM. Handle any applicable bulletins, then disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Inspect connector installation, locks, corrosion, water intrusion, weather seals, bent terminals, overheated or discolored terminals, push-back terminals, spread terminals, and terminal tension. Repair anything found. Reconnect everything fully, make sure the locks are engaged, clear the codes, and operate the vehicle under the conditions that set P0335. If the code returns after those connection checks, the path calls for replacing and programming the PCM, then verifying the repair. If the code does not return, the wiring or poor connection problem has been repaired. Keep verification separate from the testing. Anytime the repair involves a CMP sensor, CKP sensor, flywheel, valvetrain, timing chain, or gears, perform the cam/crank relearn. Skipping that relearn can cause a misfire fault to set. The takeaway on P0335 is simple. Confirm the code, separate intermittent connector problems from an active circuit fault, prove the 5-volt feed, signal, and ground. Inspect the target wheel path when the circuits pass, and only then move toward the sensor or PCM decisions the test path supports. For more diagnostic training, visit Diagnostics.com.